Your boss has asked you to write code for user stories that have been assigned to you. However, you're unsure of which database to use. For the time being, you should use any available database, so you can switch once you have a database ready. How do you ensure you can switch databases without having to rewrite the code for several days? This is where the principle of dependency inversion comes into play. According to this principle, high-level modules should not rely on low-level modules. Both should be determined by the abstraction. Keeping in mind, you can design a common interface for database code methods, abstracting away database-specific details. To achieve this, we will use an abstraction instead of relying solely on a database class using the dependency inversion principle. Now, let's create a database interface that will implement any database operations we require. And finally, we can inject our database through the client's constructor. The next step is to create a SQLite database class that implements our database interface. We will implement all 4 functions that will perform database operations within this class. So, the next thing is to create a payment report class that will make use of our newly created SQLite database. We can accomplish this by injecting the database interface class into the payment report class constructor. This way, our payment report is not dependent on the database class, but on its abstraction. Now that we have created a SQLite database class, we can create a Postgres database class that implements our database interface. Within the class, we will define 4 functions that will perform specific database operations. We will create a payment report class that will use our newly created Postgres database. We can accomplish this by injecting the class into the class constructor. Our payment report is not dependent on a database class, but on its abstraction. Here is a simple implementation of our abstraction pattern. Since we don't need to modify the payment report class to add any new databases, this approach clearly adheres to the open-closed principle. In many cases, code that violates this principle may become overly coupled, making your code difficult to maintain, unreadable, and prone to side effects. While dependency injection can be beneficial in a variety of ways, keep in mind that it is a principle, not a rule. Be very strategic when applying this principle in your next project. Your goal is to make your code maintainable and extensible.